Alright guys, so this is a review for test 1. Now I will remind everybody that you do have the ability during the test to use the little booklet if you do not have it. I can let you borrow one of mine since I've got a couple on hand. This particular question actually spans 3 questions of the test, and this is kind of the way that we're going to be working with this. The first couple of questions are actually matching. You're going to be matching symbols, you're going to be matching valves. So, and then this is going to be taking up, again, 3 questions. So you start off, we have, and this is not the exact question, guys. I've kind of varied it up so that y'all have the chance to use this as a way to study. Okay? Correct this one right here. So this is supposed to be 75 pounds. 2 inches for the first side, 4.5 inches for the second. This is a simple hydraulic circuit. So what you're looking at is going to be the force multiplier formula for this. So if you remember, the formulas that you're going to be using for this, the very first thing you're going to need to do is go ahead and solve for the area. So what is the formula for area you need to use for this particular problem? There's a couple of them. You can use pi squared r. You can do, there's my little book, I just had it. So the formula is page, so page 9 is where you find your formulas. One formula you might want to write down to have on hand is d squared times 0.785. Now the reason you want this one is because it is a very simple way to do the area that you're looking for. Okay? 7.785 is pi divided by 2, by the way. So you might want to write this down in your book. You can do it on page 9. You can do it wherever you want in the book, but you might want to have this particular formula. It's not a well-known formula, but it's one that works really, really well. Diameter. 90% of what you're given with the cylinders is telling you the diameter, telling you how wide it is. Just like any piping you use is given in diameter, not in radius or circumference. So we're giving you the diameter as 2 inches. So you have to come up with the area. Okay. It is up to you as the technician to know the area you are dealing with. So what is the area of a 2-inch bore? Well, there's a couple of different ways you can do it. You can do the mathematics of it. And there is a secondary page you can go to, page 15. If you look at page 15, you see that there is a piston diameter inches, you have a rod diameter inches, and the third column over from the left is effective area square inches. Now this is a good one to have kind of on hand for the quick ones like this where you have a 2-inch diameter. And what do they give you? We'll round that out to 3.14. 3.1416. So that would be 3.14 if you round out to the second place there. Okay, so let's go ahead and do the math. Let me bring up my calculator. We can do the math together. All right. So using that diameter squared times 0.785, so that's 2 squared times 0.785. All right, has everybody got that in their own calculator? Two squared is the diameter. You're going to be using 2 squared, which is 4, times 0.785. $3.14. So 3.14 inches squared is your effective square area for this rod, for this particular set. Okay? So our trifecta of formula is that force is equal to area times pressure. Should look a little familiar, since if you go back to the intro to electronics class, if you happen to take that, you have something similar with Ohm's law, whereby voltage is equal to current times resistance. So it should look a little familiar. So you have force is equal to area times pressure. I have found area for the first place. I already have my force, so what can I find? I can find my pressure. So what is my pressure? I would take 75 and divide it by what? 3.14. Does that make sense to everybody? Okay. So we'll say that is 23.89 psi. I want 2 places behind the decimal. Okay, so that means that I can put 75 pounds of pressure on this 2-inch piston and achieve 23, almost 24 pounds per square inch. If you really think about it, that means I'm basically per square inch, never mind, totally different thing. Don't want to get off track on this one. All right, so then we do not have 4.5 inches in our book, so we're going to have to actually calculate it. So you go back to the formula, d squared times 0.785. We have 4.5. We want to square that and then multiply by what? 0.785. We have, is this what y'all get in your calculators? Mm-hmm. 4.5 squared times 0.785. You should end up with 15 point, we'll say 15.9 because when you round that out, that's what that's going to be. That is the area of the second one. So we have 15.9 inches squared. What we're looking for here is now the force out. We know the force in is 75 pounds. What am I going to be getting as my output? Okay? Does that make sense so far? All right, so what is my force out here? I'm looking for force. Do I have area? Yes, I have my area. Do I have my pressure? Yes, because this pressure is not going to change the system, right? So, go ahead. That is your pressure. The pressure in is going to be the same as the pressure out. So we will multiply 23.89 psi times 15.9 inches squared. What is my force out? $379.8.
Reason I'm not adding the one is because the one is going to be it's going to be small in the repeated area.
379.85. That would be in pounds. That is a terrible looking 3. Yep. See if that corrects it just a little bit. That's right. It's supposed to be a 3. So 15.9 times 23.89. And you get out 379.85 pounds. Okay. So you should end up with two forces here. You have 75 pounds. You got 379 point, well, we'll go ahead and just say 380 pounds. Just to verbally round it up here, because so you have 375 pounds able to move 380 pounds. Okay? And we do that because I have a 2-inch rod, and that's my area for the 2-inch rod. I have a 4.5-inch rod on the other side, and the area for that. But the golden number is the pressure, right? The pressure is not going to change throughout the system. Does that make sense? All right, if everybody's good with this, I'm going to erase it and we're going to try another couple ones. Everybody good? All right. So y'all should remember that we did this before spring break. We would have gone a little bit differently if we hadn't had a couple of tornado scares. All right. I'm trying to draw this with the mouse, guys, so please forgive the fact that I'm trying to draw this with the mouse. Actually, I'm sorry. Wrong thing. All right, so see if this will let me do what I want it to do. So, next question, I'm going to give y'all without the little drawing just because it'll be a little bit easier. All right, so we're going to talk about a hydraulic circuit that uses a 5-inch bore. I'm going to give y'all just the basics with this. So we have a 5-inch bore. It has a 2-inch rod. We're working with 2,500 psi. And we have an 8-gallon per, or a, yeah, we'll leave it at 8-gallon per minute pump. Okay. So we're going to start off with the extend area. Yes. Hi. Um, hold on just a second. Let me pause this out. All right, so we're looking for the extend area. We're going to look for the retract area. Or the pull area is another way to call it. We're going to look for the extend force. I'm just going to shorten that to E force. The retract force. Okay. And then we'll talk about why we need something in gallons per minute in a minute. Let's go ahead and focus on these first ones. Okay. So how do we find the extend area? You can, well, you're just looking for area. So am I looking at the bore and the rod, or am I just looking for the bore? Just looking at the bore. Okay. 5 squared times 0.785. Okay, so what is my extend area? 19.62. All right. If you look in the book on page 15, this one listed as 19.635 or 19.64. I will not count off for that second decimal behind it. As long as it's something like 19.6, you're close enough in the ballpark, I'll take it. Okay? I'm not going to get nitpicky on that. Okay? What about the retract area? So that would mean you're going to have to subtract the area of the rod from the area of the bore. So you've already got the area of the bore. What is the area of the rod? Well, we already did a 2-inch one earlier, so we know that that's going to be what? So in your calculator, subtract 3.14 from 19.62, and you get what? 16.48. Okay. Again, I'm not going to quibble too much about the second decimal back there because it's just, yeah, I'm not looking for that stringent of accuracy. I'm not going to fuss about that too much. The bore is 0.785. And that gives you the retract area after you subtract the rod. Okay? Yeah. So I've given you the area, you've gotten the area, which I probably should come back and put this as inches squared, or square inches, however you want to call it. You take the bore, you square it, and you multiply it by 0.785, which 0.785 is 3.14 divided by 4. The bore is the part that's actually doing the pushing. Mm-hmm. Okay, so if I was to draw the cylinder, again, y'all will have to forgive me, I'm drawing with a mouse. The bore area is this area right here. This is all bore area. Rod area is this up here. Okay? So the reason we say we can get more force pushing versus pulling is because with the push, you're dealing with nothing but a smooth surface. You're pushing against a flat surface. When you do that, how much force can you obtain? Quite a bit, right? However, if there's something stuck in the middle of where you're trying to push, how much harder is that to push against? It's going to make it to where your force is not as great, right? So this is the bore when we're talking about this. This is the rod end, or retracting, or pulling, however you want to call it. The push side is this right here. Pull side is this one. Okay? Because generally there's something on the other end of the rod, right? Yes. Push is the bore, pull is the rod. There's about 5 or 6 different ways to say the same thing. It all means the same. Okay? Any questions on this, guys? All right, so what is the extend force? So you're given everything you need for finding your force here. That did not turn out the way I wanted it to. There we go. All right, so what is my extend force? So I found my extend area. I know my PSI. So what is my extend force? Force is equal to? So force is equal to area times pressure. I am sorry, this is really becoming difficult to try and do this with a mouse. Force is equal to area times pressure. So I've given you your area. You've got your pressure up here. So what is my force? You don't have to worry about the square. No, you do not have to worry about the square. So 19.62 times 2,500.
You multiply, that's 2,000. Decimal base now.
So you should end up with roughly 49,000. If you look in the book, it's 49,088. Page 16. Page 16. It's a good way to verify your numbers. If you're just 1 or 2 off, it's not that bad. But you should have ended up with it roughly 49,000 pounds of force. Okay, so looking at the book on page 16, you find your diameter of your rod, 5 inches. And then you can calculate, and you can look over here, and it says 2,500 psi. Follow that down to where it intersects with that 5. And you're not looking at the bore, so you're going to look where it says no rod, and that is 4988. Y'all see that? Like I said, don't really use it as a crutch, guys. Use it as a way of verifying your answers. Especially when you're doing this on a test, guys. I want y'all to be able to not only do it, but I want you to be able to verify your answers so you know you're comfortable that you're right. Does that make sense? Okay, so what is my retract or pull force? Mm-hmm. 41,200. 41,000. In the book it says 233, but again, I'm not going to quibble that much about some of this. Yep. You look for that 2-inch rod, that 2,500 psi. Where those intersect should be the answer you should be close to. Everybody see that? So 5-inch bore, 2-inch rod, 2,500 pounds should give you roughly 41,000 pounds of lift, pounds of force. Mm-hmm. Mm-hmm.
Oh, okay. It's still in the same piston spot, just the next one down. I see it now. I see it now.
Follow it down. You can see
I see
2
it
inch.
now. So I'm back up here, looking for a basket now.
You're not looking at the 2-inch. You're looking at 5 and 2.
Yeah, I see it.
Okay, yeah, I see.
So you take 5, 2, follow it across. Okay.
That's not board, that is rod.
And this is the rod and board at the same time.
Okay. Anybody got any questions on that? So this is how much force you have for the push and pull of this particular rod at that pressure. Okay. Great. What did it just do? Put it up there. Okay. All right. So y'all feeling pretty comfortable with this? Okay. So that's got about 3 or 4 questions in the test. The last one it gives is actually gives you the full. Come on. All right. So the next one, it gives you the speed formula. And that is that speed is equal to 231 times your gallons per minute divided by your area. Times your gallons per minute divided by your area. Yes, so that's got to be done first. So, all right,
Is that 8 or 18?
8. Yeah, I can't go back and erase it now because it seems to now be a permanent part of this. So it's supposed to be 8 gallons per minute. I'm trying with this. This is why I'm not a big fan of the mouse. This is why I like drawing everything on the board. Makes things a little bit different. So my extend speed. I don't know why this thing is so big. All right, so we're going to take 231 multiplied by 8. This is supposed to be 8, not 18.
Yeah, I got 94.1.
Yeah, I've been trying to make it look like an 8, but it won't look like an 8 right now. Sorry. We'll say 94.2. If you look in your book and look for that 8 gallons per minute, it should be roughly 94 for your speed on page 17. So your E speed so we'll put that up at 94. Follow that all the way down until you get to where it intersects with your 5-inch piston diameter. 94. That is your extend speed. Your retract speed So 231 times 8 and divided by 16.48. Let me try that again. 231 times 8 112 roughly. All right. So if you look, you would go stay in the 8 gallons per minute. You would go down to the section where it is 5 inches for the piston diameter. And then you look for the rod being 2 inches. There you go.
And that's for the retract, right?
That is for retraction, yes. Since it doesn't have as much area as the bore side to fill up so it will extend, it's faster on the retraction. Okay. All right. Questions on this, guys? All right. All right, guys. So another question that I know is going to be on the test is PSI A versus PSI G. So if I give you 300 PSI, that was a terrible, terrible way to do that. Bye-bye. Let's see if I can do it a little bit better on this way. "300 PSI-A", how does that translate to PSI-G? No, it's not area. What is PSI-A? Let me go back. Let me put that out there. What is PSI-A? I, huh? Doing what without writing? That's because I'm doing it on my side of this. All right, so try this again. So 300 PSIA, absolute or atmospheric, and gauge. So what is the difference between the two? What is the pressure of, what is the atmospheric pressure at sea level? Anybody remember me talking about that? Anybody else want to give it a shot? Um, like, do I try and get too far ahead of myself? 14.7 is the difference. I gotta double check my numbers here real quick before I finish putting this on the board. So 285.3 PSI G. 14.7 is the difference between the two. A is absolute, G is gauge. Gauge compensates the 14.7 that you find at sea level. Absolute does not. I'm okay, so gauge pressure compensates numerically for 14.7 psi atmospheric pressure that you find at sea level. Absolute does not. Absolute is going to take that 14.7 and make it a part of the number that you're looking at. Yes. So if I have 150 psi A, what am I looking at psi G? Excuse me. Huh? Point 0.3.
So 14.7 is the number we need to know.
Yes, it is. 14.7 is atmospheric pressure at sea level. Okay. It is incorporated into PSIA. It is compensated for in PSIG. What I mean by compensated is that it takes into account the 14.7 and leaves it out. Does it make sense? So that's the difference between A and G. Excuse me. So the reverse, if I give you 175 psi-G, what would that translate to A? Mm-hmm. If you're going the opposite way, yep. You're adding 2. Should be 200. 175 plus 14.7. Oh yeah, I'm sorry. I'm looking way too much into the different other ways. My brain's moving too fast. So 185.7. 89.7, sorry. 189.7. So 14.7 is that magic number, guys. So you might want to make sure you have that written down somewhere. Okay? And I said one takes into account 14.7, the other one does not. In other words, you can think of absolute as the absolute pressure even at sea level. At gauge would be leaving out the sea level pressure, so it would already be set ahead to 14.7 psi. Okay? And yes, guys, I am pretty much giving you the test right now, so All right, so the test one review is out there for y'all to see. It's a document, Word document. If you're having trouble with it, let me know. I'll see if I can't turn it into a PDF. Test one will plan to be on Monday. We'll do a secondary quick review right before the test. That sounds good to everybody. I will post this particular review on YouTube for everybody to have access to. Okay. I do mean everybody can get to it, and I'll make sure I'll post it under the test review when I get to that point. I'm trying to think if there's anything else we need to go over. I think that's pretty good. Yeah. All right. I'm going to stop it right there. I can find my little mouse. There we go.